Okay, so the dictionaries has both keys and values. So this is how the dictionaries are totally different to list, tuples, and the sets. And let's see. For example, why you have to when you have to use the dictionaries. For example, if you would like to have a key, which is for example, let's say name, and the person name is Rajiv. Country, which is a key, and the value is India. Company name, which is a key, and for example alcon is a value. So if you would like to have a structured data with a clean and proper understanding, you can use the dictionaries. So for example, let's say data is equal to name Rajiv, age 31. So this is a dictionary. For example, if you print this one, so it will, this is how it how it generates the data, and you take the type of this one. This is the dictionary. And so if you would, for example, if you would like to print this separately, how you can data dot items. Let's see this one. Okay, so this is how the dictionary looks like. And for example, let's say you would like to have these two separately. You can do for name value in data dot items. If you would like to have the value, print value, you can get the values over here instantly. So and if you want the names, for example, if you want both the name and this one, you can also get like this. So I mean, again, the main difference between the list, tuple, set, and the dictionary is that the dictionaries have like both keys and the values, whereas for the lists and tuples and sets, they're like single element concepts. And now let's talk about generator expressions. This is something which is like really helpful if you are dealing with like large amount of data. So let's see how this one goes. So we know that for x in range 1 comma 10, if I print x, it will print all the elements from 1 to 10, right? So like this. Now let's see the size of this one. So I'm going to import a module called get size of from system import get size of. Okay, this helps us to understand how much memory it is taking in our system for a single expression. For example, now let's say I'm going to use a list values is equal to for x in range of, I'm going to use a like 100k, and so x multiplied by 2. So so what I'm doing, I'm using a loop from 1 to 100k, and what are the value, I'm multiplying it by 12. So this is a list comprehension. And now if I look at the values, for example, let's say first 10 values, you can see this is how it will say. For example, let's first 1000 values, this is how the values are like. Now let's see the size of the data set. Print if generator on list is equal to the get size of values. Now see how much data it took. So it took 80 MB of data almost to save these many values in a list. It's like 800984. The same one, I'm going to use the tuple instead of a list and see. So values is equal to for x in range 100k, x multiplied by 2. So instead of a list, I have passed a tuple here. Print generator on tuples get size of values. And if you see it over here sorry, so if you see it over here, so it only took 208, and okay, I have to pass this one. Okay, it only took like 208 of size, of byte size, when I pass a tuple for a record of 100k, whereas for when I pass a list, it took almost like 800k, like 800k bytes of memory. So what is the difference between these two is that, so for example, when x is equal to 1, it will store in one specific data, it will store at one point of memory, and when x is equal to 2, it will take one more memory, it will take one more memory, like that. It will take like 100k different memory slots, and it will occupy all the memory in the RAM. And this I mean, to run this two lines of code, it takes like around like 800 kilobytes. Whereas here, basically what this does is that it will replace the value in the same memory location again and again. It will use one memory location, and it keeps on replacing this one. So that's the reason, if if you remember, when we were talking about a list and tuples, I said like tuples are like more effective than list. It's because tuples always helps us to replace the value in the memory location rather like taking a new slot again and again. So this is one thing. If in case if you're dealing with the large data sets, I mean, if you get a question like, hey, I have like 1 million records and I wanted you to process something, so how do you do this one? So basically you have to tell them like, what I know is like, if I use a list, it will take like lots of time for me to process that one, I mean lots of memory. So, and whereas for the tuples, it is like more fast, because whenever we are saving something, it uses the same memory location and it will replace the data in the location. Any questions?
No, got you.
Okay, cool. So now, handling exceptions. Okay, let's see how we can handle an exception. So we have, okay, let's do this one. Age is equal to, for example, input, enter the age, print entered age is age, and I'm going to keep like integer because I wanted only integers. For example, let's run this one, enter the age. If I enter 12, this will be fine. For example, let's say if I enter the ages like this one, so it is giving some it is giving me some error, which is really good. If you would like to debug this one, you can just copy, you can paste it in the chat GPT, and you can ask like, hey, could you please help me to understand what kind of error this one. But if you don't want, if you don't like to show this kind of a hard-coded error, and so for that, what you can do, you can use the handling exceptions. You can put like try at the beginning, okay, and so if whatever you put on the try, if in case if the error comes, you can pass like except. So this one, for example, if there is an error, it will go to the except, and it will print like, hey, enter a valid number. Okay, so now let's run this one. If I enter the age as 12, this is fine. Again, if I enter age as Rajiv, it is like, hey, enter a valid number. So for example, you can also put like one more, which is like else, print no exceptions thrown. If you would like to check like everything is fine, you can put this one. Let's run this one. If I pass like 12, this is like fine, no exceptions thrown. So it executed this one, there are no errors, and it came to here. For example, if I run this one, if I enter if I enter a string instead of a number, so it is like, hey, enter a valid number. So this is how you can use the handling exceptions, which is like try, except, and else. These are the three blocks that you should be remembering. Okay, the last concept, I guess, for the basics is the classes. Okay, do you have an idea on the classes?
Oh yes.
No, that's nice.
Yes, I have. I work on it. Yeah.
No, nice. So I will just try to cover it as soon as possible. So let's say you have a class point. Always have a class in the capital letters, so that you can easily identify what is a class or not. And that every class you should have a constructor to initiate. It is used to initialize the object's attributes. So usually they write like self. For example, let's say I want two parameters, x comma y. So instead of self, you can also mention like Rajiv or like Google whatever you want to do, but ideally they keep like self, so I'm keeping it as self dot x is initialization x, self dot y is equal to y. Now if I call this class point, and if I pass like 1 comma 2, and let's say one more function, define draw function self. So basically a class, it is full of classes, a constructor, one constructor at least, and a class, and one more function. So for example here I would like to print f x y. Now if I would like to print whatever the values that I passed over here, I just have to use the point, this one, dot draw, and it will pass so what it will do, whenever I pass a function here, it will go to here, and the values from here it will go to here, and the values here it is like going from here. So this is how we can use the classes to initialize the values and all. So and now let's see the same class with some variables. Okay, so I'm going to use the same class point, define, initialize the constructor self x comma y, self dot x is equal to x, dot y is equal to y, and here let's put like a value, default color is equal to red. Within the class I'm giving a color as red, and then I'm going to have one more one more function to print the x and y values. So I would like to print the x and y values here. Okay, so now let's call this class point of 2 comma 3, and if I do like point dot draw, I mean this is something we already said, it will print x comma y. Okay, 9 comma 10. Just 1 second, why it is printing 9 comma 10 here?
Yeah, that's wrong, right?
Yeah. Oh, okay. So here when we call this self, it should be like self dot x, self dot y, sorry. So here you can see 1 comma 2, and we are passing 2 comma 3, so here it should be self dot x, because when we use the self it will go to the constructor here. So this will be like 2 comma 3, and if I call so this is print, and if I call the color here, the default color, so point dot default color, so here it is a red, right? So because in the class, within the class we have mentioned it as a red, but now what I'm going to do outside the class, so point dot default color is equal to yellow. I'm overriding the values over here, which is given over here, and now I'm expecting it will print the color as yellow. So this is how you can override the values within a class by explicitly defining the variables outside of the class. So this is one thing. I mean, so basically if you think like whatever which you written inside the class is like a constant variable, so no, I mean what I'm trying to highlight over here is like they are not. So you can override that one. And now let's do some comparing objects, comparing classes, objects in the classes. So for example, let's say class point, let's instruct initialize a constructor self x comma y, self dot x is equal to x, self dot y is equal to y. And now, so for example, let's say first is equal to point of 1 comma 2, second is equal to point of, I'm taking two values here, and I have assigned the same values over here, and then I would like to match, okay, let's say this is like first and second, because I have given the same values over here, and if I run this one, it is giving me as false, though the values are really same. It's why, because whenever we want to do some comparisons or greater than something, we have to add the respective functions over here. So let's add the equal, this one equal function, equal function. So self comma other. So return self dot x is equal to um, self other, self first and second, okay, other dot x, and self dot y is equal to other dot y. So now it will return as a true or false. True. It's because we use the equality operator, equality function over here. For example, if you would like to um, check whether the greater than, for example, this is like 10, 20, and if you would like to check the greater than, the first one is like greater than this one. Okay. So how you can check this one? So we will pass a function greater than, and self comma two ones I'm taking, return self dot x greater than other dot x, and self dot y greater than other dot y. So it is like true. For example, if it is like not greater than, let's see, false, false. And also similarly, we can also have something called add, define add self other, return self dot x plus other dot x, self dot y plus other dot y. So now if I add this one, let's see what will happen. Okay, it has added 10 plus 1 and this one, this one. So this is how you can you know you can use the classes. And I mean, do you really have to use the class every time? I mean, it's up to you. So whenever I'm reading the data from Google Sheets or like Microsoft Excel, so at that time I prefer to use the classes. But I mean, you can also don't have to use the classes all the time, but whenever it comes to the concept of inheritance, I prefer to use the class. I mean, ideally, um, whenever you have to use the inheritance, for example, you define one class, and when you are creating one more class, you inherit all the majority of the elements from the main class. That is called inheritance. So those times the classes are like really handy and useful. And other than that, I don't see like any useful, I mean, especially what are the projects that I have worked on. I did not use classes much, but I thought like it's better if you can recap all the classes and all. Yeah,
Yeah.
that's all about the basics. And then if you're okay, we can go ahead and see like some 4 questions on the Python for today.
Yes, sure.
Okay.
How long do you think we have more? Because I'm getting famished. I've not had anything since morning. So it's 2:30, 2:23 p.m. now.
Okay.
How many minutes do you have more for the
Some
session? Do you
20
think we should
minutes
go
is
more?
fine.
Okay, okay.
Okay. Okay.
Okay, yeah, that's good.
Yeah, sure.